Have you ever stopped to think about the incredible engineering behind something as small as a bullet? These tiny projectiles have shaped the course of history, influenced wars, protected lives, and fueled the sport of shooting for generations. In America, bullets are more than just pieces of metal. They're part of a story that stretches from the birth of a nation to the most advanced technology on today's battlefield. Whether you're a history buff, a gun enthusiast, or just someone curious about how things work, the journey of a bullet will leave you amazed. From molten lead and shiny copper to precision-crafted ammunition ready to hit its mark, the making of a bullet is a fascinating process you've probably never seen up close. And stick around because at the end of this video, we've got a surprising reveal about different bullet types that even seasoned shooters might not know. Ready to load up? Let's dive into the story of America's bullets. But before we begin, hit that like button and subscribe for more behind-the-scenes looks at the processes that keep the world moving. Bullets have played a vital role in shaping the United States, not only in military history but also in law enforcement, competitive shooting, and personal defense. From the dusty battlefields of the Revolutionary War to modern-day shooting ranges, bullets have remained essential tools of power and precision. Each firearm depends on the right ammunition to deliver maximum accuracy and performance. A 9mm round for a Glock pistol, a 12-gauge shell for a shotgun, or a 5.56mm cartridge for an AR-15 rifle. Every type of bullet has a purpose, whether it's for close-quarters defense, hunting big game, or long-range target shooting. The choice of bullet can make the difference between hitting the bullseye or missing the mark entirely. But how do we go from raw chunks of metal to a perfectly balanced, high-speed projectile? Let's start by traveling back in time to see where it all began. The history of bullets in America is deeply tied to the history of firearms. When European settlers first arrived in the New World during the 15th and 16th centuries, they brought muskets that relied on simple lead balls, known as musket balls. These were round projectiles that had to be loaded manually with gunpowder, making them slow and cumbersome to use compared to today's technology. Still, they were revolutionary for their time and gave settlers a critical advantage in hunting and survival. Fast forward to the 19th century, and the development of the mini-ball changed everything. This conical bullet, paired with rifled barrels, dramatically improved accuracy and range, making it a game-changer during the Civil War. Soldiers who once relied on smoothbore muskets could now strike targets with deadly precision at greater distances. But the real breakthrough came with the invention of the metallic cartridge. For the first time, the bullet, gunpowder, and primer were combined into a single, self-contained unit. This innovation made firearms far easier and faster to load, transforming warfare, hunting, and personal defense forever. By the late 19th and early 20th centuries, bullet technology had advanced even further with the introduction of jacketed bullets, lead cores encased in harder metals like copper. These new designs allowed bullets to travel at higher speeds without damaging gun barrels, making them ideal for military and civilian use alike. As time went on, specialized bullets emerged, hollow points for self-defense, armor-piercing rounds for military applications, and soft points for hunters who needed deep penetration without overexpansion. Today, bullet technology in the United States is at its peak, with innovations like polymer-tipped projectiles for superior aerodynamics and bonded bullets that hold together even after impact for maximum stopping power. Modern ammunition isn't just about speed or power, it's about precision engineering for specific purposes, whether that's law enforcement officers who need controlled expansion to avoid overpenetration, hunters seeking ethical kills, or competitive shooters chasing ultimate accuracy. Now that you know how important bullets are and how far they've come, let's step inside the factory and see how they're made. Before we do, here's a quick challenge for you. What color are tracer bullets when they're fired? Drop your answer in the comments and we'll reveal it later in the video. The bullet-making process begins with raw materials, lead and copper. Lead is the heart of the bullet, forming the dense core that provides weight and penetration. Copper, on the other hand, creates the protective jacket that surrounds the lead core, allowing the bullet to travel at high speeds without deforming or leaving lead residue in the barrel. The journey starts with massive ingots of lead delivered to the factory. These ingots are melted down in giant industrial furnaces, reaching temperatures high enough to turn solid metal into a glowing liquid. At this stage, the molten lead is purified to remove any impurities that could affect performance. Meanwhile, copper arrives in large rolls or sheets. Before it becomes a bullet jacket, it too is inspected for quality because any flaw could compromise the integrity of the finished product. Once the lead is purified, it's ready to be shaped into cores. There are two primary methods for this: casting and swaging. Casting involves pouring molten lead into molds, where it cools and solidifies into small cylinders. Swaging, on the other hand, uses high pressure to compress pieces of lead, called slugs, into precise shapes inside a hardened steel die. Swaging is often preferred because it produces highly uniform cores with consistent weight and density, which are crucial for accuracy. Every tiny variation can throw off a bullet's trajectory, so precision here is everything. Next comes the creation of the copper jacket. This process starts with thin discs of copper, called blanks, which are stamped from larger sheets. These blanks then go through a series of drawing operations. Each step progressively stretches and shapes the copper until it forms a hollow cylinder, open at one end. This cylindrical jacket will eventually house the lead core, creating the basic structure of the bullet. The copper jacket isn't just for looks. It plays a critical role in ensuring the bullet withstands the intense heat and pressure of being fired while maintaining its aerodynamic shape in flight. After the jackets are formed and the cores are ready, it's time for assembly. Each lead core is inserted into its copper jacket with extreme precision. Depending on the bullet design, the core may be bonded to the jacket through a heat or chemical process to prevent separation upon impact. For certain bullet types like hollow points, the tip of the jacket is left open to allow for controlled expansion when hitting a target. Others, like full metal jacket rounds, have a completely enclosed core for maximum penetration. Once the basic bullet is assembled, it's trimmed and polished to exact specifications. Length, weight, and diameter are checked down to the thousandth of an inch. Any bullet that doesn't meet these standards is rejected because even the smallest imperfection can affect accuracy. The bullets then undergo a final quality control process, which often includes high-speed imaging and even X-ray inspection to ensure internal consistency. But we're not done yet. Bullets don't work alone. They're part of a cartridge that includes a brass case, gunpowder, and a primer. The brass case is formed in a similar way to the copper jacket, starting as a small disc that's drawn and stretched into a cylindrical shape. After several forming steps, the case is heat-treated to ensure strength and durability. Once complete, the primer is inserted into the case, followed by a carefully measured amount of gunpowder. Finally, the bullet is seated on top and crimped into place, creating the finished round that shooters know and trust. Before these cartridges hit the market, they're put through rigorous testing. Ballistic labs measure everything from muzzle velocity and pressure to accuracy and consistency. Test rounds are fired into ballistic gel to analyze expansion and penetration, ensuring that each bullet performs exactly as intended, whether for law enforcement, hunting, or self-defense. Only after passing these tests can they be packaged and shipped to gun shops across the country. And now for the answer to our discovery challenge. Tracer bullets typically burn red when fired, thanks to the chemical compounds in their base that ignite and produce a bright, visible trail. These are often used in military applications to help shooters track their shots during combat.